Hi folks, welcome to Lesson 6, Quantitative Chemistry with Appraisal and Science. We're going to use the same format as per usual, so if you need to pause the video and collect resources, do so now, or if not, you can copy straight from the screen. You will need your periodic table again. You're going to need your calculator. Okay, here's Retrieval Practice slide number 1, so pause and retrieve. Here are the answers, so you can check and revise. Questions number 2 are here, so pause and retrieve. Here's the answers, so pause, check, and revise. And the final set of questions are here, so pause and retrieve. And here's the answer, so you can check and revise. Today we're going to look at calculating something called reactive masses. You're going to need several documents from Show My Homework. Again, you can copy straight from the screen if you need to. This is the first document. And then the slot questions start here and end here. Okay, let's start today's lesson, calculating reactive masses. The first question says, in a chemical reaction, what is meant by the conservation of mass? And we've done this before, so we'll do this quite quickly. Conservation of mass states mass of reactants will equal the mass of the product. And essentially we're going to be using that rule today. But let's have a look at a couple of these types of calculations. Question 1 says, calculate the mass of iron sulfide. Just going to circle that. Produced when 5.6 grams of iron reacts with sulfur. And then I've got an equation underneath, Fe plus S, that's iron, that's sulfur. This is iron sulfide. So I'm just going to annotate this with what it's told us in the question. It says, calculate the mass of iron sulfide. So that's the question. It's produced when 5.6 grams of iron, so 5.6 grams of iron reacts with sulfur. And what we're going to do first is we're going to write down the relative atomic masses or the relative formula masses of each of these things in the equation. You're going to need your periodic table. Remember, we're going to use the mass numbers. So iron has a mass number of 56. Sulfur has a mass number of 32. And iron sulfide is going to be 56 plus 32, which is 88. Then what we're going to have to do is convert our 56 into 5.6, because that's what the question is telling us. And to do that, there's a fast way and there's a slow way. We're going to do it the slow way, because the slow way will always work when things get more difficult. So we're going to convert it into 1 first, 56 into 1. I'm going to convert 56 into 1. We divide by itself, 56, and then we convert 1 into 5.6, or times it by 5.6. Now what we have to do to solve this now is what we've done on this side of the reaction, we're going to do on the other side of the reaction, using the same numbers. So I'll show you that now. Of course, you're going to need to use a calculator to do this when you're on your own. So that's the first one. Now, essentially, we just use the same principles we've done there in all the other questions we're about to do. So that's question number 1. Question number 2, let's read it. Calculate the mass of hydrogen and fluorine required to make 144 grams of hydrogen fluoride. So look, this is hydrogen, this is fluorine, this is hydrogen fluoride. So let's just annotate the equation. So calculate the mass of hydrogen and fluorine. So I'm putting question marks over those two to make 144 grams of hydrogen fluoride. Again, all we have to do is write the relative formula mass underneath each of the things in the equation using the top numbers. So hydrogen has a mass number of 1. There's 2 hydrogens, so that's 2. Fluorine has a mass of 19, but there are 2 fluorines, so that's 38. And then here we have hydrogen is 1, fluorine is 19, so that adds up to 20. I've got a balance number in front. I've got to use that balance number, which says I've got 2 lots of it. So that's 20 times 2. 20 times 2 is 40. Now, what we're going to do next is convert our 40 into 144. Same principle. Convert it into 1 by dividing by 40, and then convert it into 144 by timesing by 144. Whatever you do on this side, dividing and timesing, you do it for the things that you're being asked to solve in the question, which is both of them this time. So I'm going to do that now. That's the answer to question 2. Question 3 says, calculate the mass of magnesium oxide produced when 10 grams of magnesium burns in air. So calculate the mass of magnesium oxide. There's the magnesium oxide, that's the question. When 10 grams of magnesium burns in air. Let's put the mass numbers underneath. So 24 times 2, 48. I'm not going to do the oxygen this time because it's not asking us about that in the question, but now I'm going to do this one. So I've got 24 plus 16. It's 40 times 2, that's 80. Now again, I'm going to convert this to 1. By dividing by itself. And then convert it to 10. Because that's what's been asked in the question. And then I just do the same on the other side, which I'm going to do now. So that's question number 3. Question number 4, calculate the magnesium needed to make 20 grams of magnesium sulfate. So I have magnesium, so calculate the mass of magnesium. And then over here, I've got magnesium sulfate. We need to make 20 grams of it. So put the mass numbers underneath. Magnesium sulfate, you might need to use a calculator, but you've got magnesium is 24, sulfur is 32, and then you've got 4 lots of oxygen, which is 4 times 16, and that comes to 120. Add all that together. So starting here, I've got to convert 120 into 20. So that's the known in the question. Divide by itself. To get 1 times by 20. To get 20. Do the same on the other side. That's the answer to question number 4. And the last guided practice question. Let's calculate the mass of calcium oxide produced when 60 grams of calcium is burned in air. So we have 60 grams of calcium. Here's the calcium oxide. That's the question. Put the mass numbers underneath. Remember the balance numbers. This is 2 times 40, so this is 80. And then again, we'll have to do the same process here. If you 2 times calcium oxide is 40, plus 16 is 56, double it, make 112. And then we need to convert 80 into 60, convert to 1. By dividing by itself, it comes by 60. Get your 60 grams, and then do the same on the other side. Okay, so that is the answer to our last question there. Okay, it's your turn to practice now. So I have these questions on Show My Homework, which can be printed straight out, or you can do them straight from the screen. However, remember to leave space in between to do your workings out. So questions 1 to 4 are here. Questions 5 to 8 are here. So pause the video and complete the questions. And the answers to the questions and the workings are here. So here's questions 1 to 2, 3 and 4, 5 and 6, and the last 2 questions. So that's it for today. Thanks for tuning in, and we'll see you for the next lesson.